All right. So let's open a let us open Jupyter Lab. So we will go down to applications, Python. It's recommended that you use Jupyter Lab because that's newer. Jupyter Notebook also still works, though. I'm just going to go ahead and use Jupyter Lab, though. So we'll select an hour since that's all that's left for this session. I am not going to touch job settings. Everything that you should need for Jupyter Lab, and the same is true for Spider. Everything you should need is configured in the background to be loaded. So most of the standard packages, and even quite a few of the non-standard packages like Seaborn and some of the sklearn and some of the machine learning applications, not necessarily including PyTorch or well, it depends on the version, which one includes PyTorch or which one includes TensorFlow. But most of the other applications like matplotlib, Seaborn, Pandas, all of that stuff is included when you load Spider or Jupyter. So don't touch job settings. 99 times out of 100, you won't need to. So let's just go ahead and start.
Yes, and a comment here is if you are using a virtual environment to run your Spider, you have to actually explicitly install all the packages you need inside the virtual environment. You can't use the module system because the site packages will not help you here. I mean, the Spider will not recognize it. It's a weird thing, but this is what I found the days before here. So
Yes, sorry. On other facilities, if you want to run Spider anywhere else other than LUNARC, or if you want to run Jupyter anywhere else other than LUNARC, you need to load all the other modules that you need first, and then start Jupyter. Because if you forget a module, then you'll have to close the Jupyter or Spider down and load it, and then reopen it. So anyway, so now that this Jupyter Lab is open, what you see over here is you'll have the main coding pane where you can, if you click this little plus sign, you'll get the launcher. And then over here on the left, you'll see a few different menus. The one that has the file folder is your file browser, and you can use this to find previously made code. So let me close this briefly. And I had started to work on this a while back, so I'll just double click this and open it. Other things you can do are click this little table of contents, and if you've got a notebook open, what it will do is if you've given it different markdown headings, it will show the nesting levels of the markdown. There's also this running terminals session. So it tends to not shut down kernels of files that you've closed on their own. So what you typically have to do is like click these buttons and so like let me close this again. So this is that's now closed, but the kernel is still there. So and if you click it, it pops right back up. Whereas if I close this and then shut down all, then now now if I go back to this file window, the little dot next to it is gone. That means the kernel is shut down. So if a kernel is running, you'll see a little green dot next to your file. And so I'll just go ahead and reopen that. If you wanted to make a new file, then you could just do a new notebook by clicking this, or you can open a console, or you can make other types of files here, like text files or markdown files. I've only ever used notebooks. So let's just see what it does while it's built in with built-in stuff. So let's print hello world. You can print, I'm going to change this so that you can actually see that it's something else, kind of, I don't know, 3. So that imported NumPy and then printed sign 3, and then you can do some other stuff here, like import pandas and assign this little data frame and print it. And it's got some random values, so I'll just plot. And we'll see a little bit more tomorrow that with pandas you can call plot methods off of the data frames without having to go through matplotlib, although it's a little bit more bare bones. But anyway, this is kind of how you would use Jupyter Notebooks. So let's import matplotlib, and this will be different. This will be different for what I did not compute this random array. So I've made this random array, and now I want to plot that against this index. So I do plot.plot, some indexes, and then the array I just defined. And now you get something that looks like this. Now in JupyterLab, sometimes you have to add this line when you import matplotlib. So matplotlib inline. And that changes the back end a little bit, but it's not always needed. Anyway, so with the time that we have left, I will go to the matplot document, which was adapted from a much longer lecture and will most likely be longer in the future as well, when we present it at future versions of this meeting. But I'm going to have to skim it this time around. This is brand new material, so I hope you'll bear with me a bit. So when you're starting, this is a little bit more about helping you with your code. So before we get started, let me pause my share, or rather, let me stop sharing briefly, and I want people to raise their hands if they've never used matplotlib. All right, so now everyone sees my screen again? Okay.
Yes.
Good. All right, so before we dive back into matplotlib, I just want to make sure that everybody knows a few terms. So when we're hopefully everybody has plenty of Python experience, at least apart from matplotlib. But just to remind people, when you see the words args and kwargs, what they refer to are positional arguments and keyword arguments, respectively. So when you're calling a Python function or a method off of an object, you get some you might have to give it some terms in parentheses. If they're given without having a word with an equal sign next to it, they're usually positional. They're positional arguments, and they're usually mandatory, and they always come before the kwargs. And then the kwargs are typically optional, and they're given as like the name of the kwarg, an equal sign, and then the value of the kwarg. And sometimes functions will have like a kwarg's kwarg, where you have to pass in a dictionary of key value pairs that are passed to an underlying function that have where those keys are kwargs and the values are the values you're passing to those kwargs. We'll see a couple of those later in this material. They'll also help you remember what classes, methods, and classes are the templates to make Python objects. They have a built-in init function. That lets you set initial properties that that have to be defined when an object of this class is created. So, like when you're defining a NumPy array, that's a class, and you have to give it some values to initialize it with, because you can't just initialize space for an array without creating the array object. And then you have methods and attributes. Methods associate functions with an instance of a class, and that allows quick evaluations for each class instance. So, like, let's say you have an object that's of type myClass, and it has some method that is called myMethod. Then what you would do is object.myMethod parentheses and maybe pass in some args or kwargs if any of them are necessary. Attributes, on the other hand, just store values. So they don't take any arguments. You just pass in the object.myAttribute, and then it either saves or prints a value. Okay, so now we can get to the loading and running of matplotlib. And I don't have an NSC tab for this crap. So on HPC2N, matplotlib is, whoa, what is happening to my mouse? If you use matplotlib at the command line, after importing matplotlib in your script or at the command line, you'll need to add a line that says matplotlib.use parentheses tk enter. And what that will do is that, so normally if you leave it with the default backend, a lot of times what will happen is that when you make a plot, it'll just print a couple of, print the less than and greater than signs, and then like the name and code of an object inside of that, but it won't actually show the figure, even if you type plot.show. With the correct backend, the plot will actually pop out in its own window, and you can view it. But if you don't want to have to mess with backends, it's better to use a GUI, so like JupyterLab or Spider. But you will still have to preload matplotlib and any other modules that you want before loading it. Command to start JupyterLab, we already went over. It was already shown, and Spider launch command on HPC2N is Spider 3. And that launches that old version of Spider. Whoops. God, my mouse is too sensitive. Whoa. Sorry, my mouse is a bit touchy. So as of last month, module load Spider module Spider matplotlib shows the following outputs. So it goes up to matplotlib 3.8.2. And on Cosmos, again, you typically would want to use Spider or Jupyter, although you are able to use script files and just run them at the command line. I just don't recommend it. If you are going to work on the command line, again, you need the matplotlib.use tk enter extension. And if you are working on the command line, you also need to load all the prerequisite modules and then matplotlib. On LUNARC, matplotlib goes up to 3.9.2. And on UPPMAX, at UPPMAX, if you're on Rackham, loading Python 3.8.7 or newer will allow you to import matplotlib, numpy, scipy, and all of that stuff implicitly without having to load anything else. If you want Jupyter, Pandas, and Seaborn, those and matplotlib and numpy and scipy and everything else are all loaded together with one of the versions of Python_ml_packages. And yeah, there are a couple of versions on available here. The one that's recommended is 3.11.8. So see, I don't think that I can. Okay, last time I tried running two thin link windows at the same time, it crashed my my Zoom session. So I'm not going to do that. But I will keep the. I do have this demo. So I have this demo notebook open where I can run some of the matplotlib scripts as needed. I forgot to mention, if you're on Rackham and you need to use a much earlier version of Python for like 3.7 and older, then the matplotlib package is separate. And you would want to load it with one of these options. And some of them you'll see have the Akuda option if you want to use some GPU acceleration. I don't have time to touch on those right now. We'll briefly cover Numba acceleration in Pandas tomorrow. And on Rackham, the native backend should work if you're logged in via ThinLink. But if for some reason it does not, the option that you want, and I thought I put it in here yesterday. If for some reason the native backend on Rackham does not work, I can put in the chat the alternative, or I'll put it in the Q&A documents later, well, I'll put it in there now. So if the native backend on Rackham doesn't work, you can use Qt5 ag with the matplotlib, the matplotlib lib.use, like that. But try it with the native backend first. It should work. We only had a couple of people have to use this. So let me go back to the rest of the matplotlib session. All right. So when we talk about matplotlib, the application interface has a few basic components. The first thing you do when you create a matplotlib plot is to make a figure instance, and a lot of times you also initialize an axis instance at the same time. The figure is the blank canvas where your plot appears, and the axes are where the data are the grids, and where the data and the increments and the labels and stuff are drawn. Each individual axis is also its own object, and it's tunable. You can control the labels, the increments, the scaling, text format, etc. And if you want to refer to any of these objects or all the other objects that are available, that is created by a matplotlib command, everything is an object in Python. And in matplotlib, every object is something called an artist. So that's every axis, every data set, every polygon you draw, every annotation, every legend, etc. The word the artist doesn't typically come up unless you're doing something like drawing a polygon or if you have to make a color bar. So the main ones that you want to remember are figure, axes, and axis. For everything else, for the rest of the terminology, there's this anatomy of a figure plot that is also, this is copied directly from the official documentation, and in fact, it links back to it.
We need a
So,
break very soon.
all right, so we were at the elements of a plot and fig and ax and all that stuff. So if you see on this plot, you'll see a whole bunch of things that say ax dot this, or in some cases fig dot, although that's not on this figure. Oh yeah, there's one. Fig dot subplots. You'll also see it if there's a color bar. There'll be like a fig dot color bar. Let me close my door. Okay, so what are those terms? So there are two choices of application programming interface in matplotlib. I showed one earlier where I just did, plot.plot. That is the implicit API, and that's a quick and dirty way to visualize isolated data sets if you don't need to fiddle with formatting and if you don't need to add any additional data sets. What is recommended, however, is to use this explicit API. And that gives you actual handles for the figure and the axes objects. Those are typically denoted fig and ax or axes if there are multiple. And that way you can adjust the formatting or accommodate multiple subplots. So most people's first attempt at a matplotlib plot will look like the one I just showed you, where you have, plot.plot and maybe some, maybe plot.x label, plot.y label, plot.title. Those are just implicit ways to specify the axes, labels, and title. And the result looks like this. But if you want more, options, the explicit API is generally the way to go. And the way you specify it is with this fig, axes, plot.subplots. You can specify rows or columns if you want more than one, but even if there's only one set of axes, you still typically want to use plot.subplots, and then you just leave the statement in parentheses empty except for figure specifications. So the counterpart of the previously shown code is this one. I will go ahead and copy this over to this code demo here. Scroll down to an empty space. That way I can run it in real time. So I'll set the set x equals to this line space and then calculate a couple of trig functions. And then I'm going to add a legend, so that looks like this. You see the demo plots with the legend, the x and y axis labels, the title. And one thing I want you to notice is that these labeling, these formatting and labeling commands for the titles and the axes, if they're called as a method of plot, with the implicit API, you typically don't need this set. Whereas when they're called as a method of axes objects, then they have this, set underscore in front of them. Typically. There's lots of different ways to give yourself plots and subplots. And For the standard plots, subplots, then you just, if you have a 2D array of plots, you'll specify both in rows and in columns. If you only specify one or the other, it'll be a 1D array. And the indexes will be a single number. And if you leave this, if you don't specify in rows or in cols, so you just have one figure, then axes will not be iterable. So if this were a two-dimensional plot, like let's say I had 2 rows and 2 columns, then these axes here would be would have like an index, comma, another index, which would be for the rows and columns. So just to show you how this would run at the command line, I'm going to copy this to I'm just going to open a standard Emacs file, open and I'll just open something in my home directory since this is tiny. Documents, demo plot.py. Okay. Then paste all this, and then instead of this matplotlib in line, I'm going to import matplotlib PL, and then npl.use. Per the advice that I just got, it was tk-ag instead of tk-enter. Save that. And now what I'm going to do is minimize this. I'm going to open a CPU terminal here and just give it the time that it's already got. Then cd documents. Yeah, there's demo plot right there. So now I need to, because this is a terminal instead of Spider or Jupyter, before I can run the script file, I have to import all of the associated packages. So I'm going to do ml spider python, oops, lowercase. Double check which versions are available. I'm going to use Python 3.11.5. So let me check what I need to load before I do that. And this should show like a GCC version. Yes. So I typically load GCC instead of GCC core because the GCC core is more bare bones, and a lot of times other modules that you need to load also require the full GCC. I think matplotlib requires the full GCC, so I'm going to just load GCC. Python. Now, if you load GCC, then you don't necessarily need to specify the Python version. In this case, I will because I'm not 100% sure that it will pick 3.11.5 instead of 3.11.3. But the other thing I will go ahead and load is SciPy bundle, because that gives you matplotlib, or not matplotlib, that gives SciPy bundle contains NumPy, and almost everything you do in Python, you'll need NumPy, so you'll have to import SciPy bundle. Oops. What happened there? Oh, I didn't capitalize it. Oops. There we go. Now I can just check ml avail matplotlib just to see what it will load. And it's going to load one version, so I don't actually need to specify the version. So I'll just do ml matplotlib, and now we've got it. And now we can do Python demo plot.py, and let's see what it does. There we go. It even popped up the figure for us. And here the configuration buttons are down here along the bottom. You don't have the option to adjust this way you don't have the option to adjust any of the content of the figures, but you can adjust the spacing around and between the subfigures. So I'm going to stretch this a little bit more towards the top, like that, and towards the right, just so you can see it, and let it go like that. And of course you can save the figure like that. I'm going to go to, wow, that is a long list. Just going to go back to documents, and I'll leave it as figure 1. Save, and that's done. So that was a little bit tedious, not bad, but it is a lot quicker if you just do it in Spyder. So what I'm going to do in Spyder is I'm going to open the file and go back to documents, select demo plot, open, and now all I need to do to run it is click this green arrow. Oops. Okay, so here you need a different extension. So you can try, actually, I will try the default first and see if, yes, that will work. So then it pops up the same GUI as you saw before, but you have a little bit extra of extra options. So you can go to this, yes, so here you can select different axes. So this one selects the bottom one. And if I change my mind, I can, there's only one curve on that axis, but if but yeah, you have the option of selecting different subplots and editing them separately. And you can edit the legend as well. But let's say I wanted to add more plots. So let's say in columns equals 2. Now I have an issue because I need to change the indices of these like this. Let's see. And I have to, I'm going to add a third plot at the 1 by 1 position. I don't have to, you don't have to add axes at all 4 locations, but I'm going to do like a 0.5, and let's just change that to a minus and make this green and dot. Or actually magenta, since that's supposed to be better for color blindness. And change the labels. So ordinarily what you would have to do is that if you were writing this script in the command line, in the matplotlib prompt, you would end up having to X out of or leave you would have to leave your the command line and reopen it, or you would have to go back to your scripter and toggle back and forth with the command line, and you might even have to reload some modules. But all I did here was, and actually for this, I'm going to put set plot.title so that it's a, I so that it titles the entire plot. So now all I have to do to rerun the file is click the green arrow again. That just happened. Oh, that's why. I'm going to skip that. Too long to edit. Dang it. Oh, that's why. Okay. See, lots of experimentation. And all you have to do is, go to the scripter, click the green arrow. Go to the scripter, click the green arrow. This is why I like Spider. Everything is all in one place, and all you have to do to rerun your script is click the green arrow. So the title obviously didn't land in the right place, but that's okay. We don't really care. This is a demo plot. All right, and it did launch the others. It just yes, sometimes it will pop up the figure, but if it manages to create the figure before hitting the arrow, you will get the figure. It just will end up in the background. Anyway, so let's go back here. There is one other way to make, there are a couple of other ways to initialize subplots. There's also the plot.subplot and fig.add_subplot methods. They require more code to put more than one plot on a single figure because each plot must be added one at a time, and there can be no more than 9 plots on the figure. But they do offer one benefit, and that is that you can have different coordinate projections on each subplot. So in this example, I had one of the plots be in polar coordinates. So I put figure equals plot.figure, I set the figure size. And then in plot.subplot, I specified the positions of the first axis object at 1, 2, 1. That means there's 1 row, 2 columns, and the third digit is the position of the current axis. So that's 1, and that digit goes up to 9. So the first 2 digits each go up to 3, and the second digit, or the third digit, goes up to 9. So the first axis object, same procedure as before, ax.plot, set the labels, add the legend. For the second axis, again, I have to add it manually, and I set the it's 1 row, 2 columns, and this is the second plot. And this one, I gave the projection of polar. And then from there on, it's the same as before. But instead, when the figure is produced, it's in polar coordinates, like that. I already described that. Then there's a final alternative, which is the subplot mosaic. And that allows you to easily set subplots to span multiple rows or columns. Each plot is identified by a single ASCII character, and when you lay out the alignment and configuration string, multiple occurrences of the same character will be used to indicate where the plots span multiple rows or columns. It'll make sense in a minute when you see the demo. And the full stop character is used to denote gaps. And you can use the semicolon to separate lines instead of putting them on separate lines for more compact code. And there's also a per subplot KW kwarg, and that accepts a nested dictionary where you give the single character plot labels as keys, and then the values are themselves dictionaries with axis methods specified as the keys and the values of those methods set as the values. So here's an example. It's the same plot as before, where I'm just computing some trigonomic functions. So I give this So I've got A, B, B, A, C dot, and D, D, D. What that means is that I've got a 3x3 grid. Plot A spans the first two rows of the first column. Plot B spans the second and third column of the first row. C occupies exactly the one space in the middle, and D occupies the entire strip along the bottom. And just to be extra, I made the plot C polar projection, and I made B and D scaled log scale. And then I formatted each of the axes with I printed the label of the plots on the plot itself with ax.text. And then these are the plotting commands. And this is what the result looks like. So they're only B and D actually have data on them, but this is how the layout looks when you make the subplot mosaic. Now for controlling the display, there are a few, okay, this is where I talk about the TK enter and QT5 ag, and some of these need to be fixed, I think. Because there was some mix-ups between what was applicable in Spider and what was applicable at the command line. So we already covered Jupyter and Spider, and we already went over the preferences and the graphics. So matplotlib uses the default resolution of 100 dpi, and these dimensions. And in Jupyter, there's an even lower res default resolution of 80 dpi, but you can use the dpi quarg of plot.figure or plot.subplots to change the figure resolution. And you can use fig size as well to change the apparent figure size. Now, if you want to save your code from the command line or from inside of your script, there's the plot save figure, which takes some of the same format commands, formatting quarks from figure. And if they're not specified, like the default DPI is inherited from figure or subplots. And if transparent is true, the typical white background is removed, so you can display it on top of other content. There's also plot.msave that's specifically for saving arrays to images. We will not, this is not demonstrated here. There are a ton of different standard plot types, and I am very low on time, so we're not going to go through all of them. Let's just say there's about 40 of them. There's pairwise plots, statistical plots, gridded. There's plots for gridded data, irregularly gridded data plots, and volumetric data plots. If you go to the official matplotlib documentation, just use the last one. Go to plot types. They will go over, this page includes all of the different plot types, or most of the different plot types. And you can click on any one of these examples and see all of the args and quarks of them. So let's just say, I'm hovering over Hexbin, so let's see what Hexbin offers. Here's a little example that shows you some of the arguments. And then you can also click Hexbin here to see the full list of args and quarks and what all the parameters mean. So we've already covered all of those. I'm going to skip to formatting and placing the plot elements. There are two functions for adding text to plots at arbitrary points. You can use annotate or text. Text is the base function. I just showed it in the subplot mosaic. What it does is it adds and formats text only. Annotate also include some quargs where you can specify like an arrow or a connector patch between the points and your text. And you give separate coordinates for the points and the text. In both cases, the positions are given in data coordinates unless you specify this transform equals ax.transaxes. And what ax.transaxes does is it switches from data coordinates to axis relative coordinates, where 0, 0 is the origin of the plot, 1, 1 is the top right corner, and values that are less than 0 or greater than 1 are outside of the axes, which the figure area will stretch to accommodate up to a point. For legends, it's typically enough to put plot.legend or ax.legend, but there's an LOC or lock quarg where you can specify the location more precisely. And you can do that verbally. There's also a bbox to anchor argument that allows you to put the legend outside. For math text, if you want to typeset your figures for appropriately for publication, you'll need to know a little bit of LaTeX or LaTeX syntax. I'm not going to go into much detail about that, but you can follow these links to see what characters are supported and what some of the syntax is. If you have a really old version of matplotlib for like Python 3.7 or lower, you might need to install LaTeX separately or to give yourself some really obscure characters. Otherwise, the native installation should do. Unfortunately, Python and LaTeX both use curly braces, and they both use some other characters as well as part of their functions. So it's a little bit awkward adjusting for the collision. If you use string.format, all of the curly braces associated with LaTeX commands have to be doubled. And that includes nested braces. So you can end up with a very long series of braces. Some characters also require the whole string to have an R in front of the string in order to correctly render certain characters like the times symbol or the plus minus symbol. Most basic operators can be used as is, but a few like the $ and the percent sign need to be escaped with a single or double backslash to prevent them being used as a function. And spaces within any character sequence that's between two $ are not rendered. So you'll need to insert spaces with something like a backslash semicolon or a backslash comma, unless you want to split up the LaTeX sequence. So you can use string insertion inside of formatting operators, like the superscript and subscript commands, but it can require a lot of extra curly braces, but it is still doable. And this example below shows you what you have to go through in order to, if you want to, let's say you have this velocity vector and you want to list the asymmetric error margins and you want a nice proper vector symbol on it and vinit and all of that stuff. For the proper typesetting, you need this entire command and you cannot split up the line. But it is doable. And all of these places where you see the curly brace, colon, and then like a string formatter operator, that's where the parameters that are passed to format are inserted and formatted. We're running low on time, so Axes objects have a lot of different methods for formatting them. We already saw the labels and the titles and legends. You can also turn on a grid. You can adjust the X and Y limits to change what bounds are shown. You can change the scale so that you can show log scale or logit or a sin h or marketer even. And then there's a function and function log option. And what function allows you to do is it lets you define a custom transform. So like, let's say you have one axis that's in wavelength and you want to show a second axis that's in frequency of light. That's a fixed transformation and you can define that. But the trick is that you have to define both the forward and the reverse transformations. You can invert the X and Y axes. They do exactly what they tell you to. Secondary axes and secondary Y axes turn on axes on the top and right side, so that you can either tie them to the primary axes by transformations, or you can make them totally unconnected. And note that any method that has a set in the name also typically has a get counterpart that returns the current values, so that you can use a setter method to override it. And you may have to adjust the tick spacing and tick labels if you need to, if you have any of these special circumstances, like qualitative variables or axis tick labels that are centered between major ticks, or log scales with a large number of decades, or secondary axes. I have an example here in the documentation that we're almost out of time, so I'm not going to talk you through it, but the documentation is here and it's annotated. So if you want to do it in Jupyter, I'll show what the results look like in this demo code here. So stop moving. Okay, so don't need any of that because it's already imported. And if I run this, what it does is that it's the wavelength axis has been transformed to a frequency axis on the top. And then this intensity axis I've formatted to show more than 7 decades and have logarithmic ticks every 1/5 of a decade instead of 1/10, which is the default. And I had an extra function in it that put a rainbow on this, but I deleted it because it was too complicated. One last part, placing and formatting the color bars. One important thing to be aware of is that color bars are methods of figure, not axes, in the explicit API. So you have to pass each axis object separately to each color bar explicitly. The plot itself, you have to assign the plot itself to a variable name that you pass as the first positional argument of color bar. So if there are what this allows you to do is to have multiple color bar, or you can have multiple color bars in the same plot, and you could have one color bar that covers several axes. Whoops. So Jupyter Lab just expired for me, so I'm going to close this and come back right here. There's an extend quag that lets you show that the axes, that the color bars extend beyond the limits of your color map, or that they've been truncated to maintain contrast. And there's also a shrink quag that helps resize the color bar to match a plot's width or height, which can be which matplotlib often does not do very well. Ticks and color bars are inferred from the plot by default, but you can override them with ticks and format quags in color bar. And you can also set the color bar title as an argument of color bar. So I have an example here that shows a couple of different image plots. And so I have 2 images where I've mocked up a where did I define Z? Anyway. So I defined an image, somewhere I defined an image array Z and then plotted the, okay, so I will probably have to add that somewhere else. Anyway, so I had these two images, Z1 and Z2, that are basically just a Gaussian. One of them is offset like this. And I've given them a couple of different color maps and color map normalizations. The second one is log normalized with and only shows values down to 0.01. And that's in order to show that, and that's so that the color bar is contrasty enough. So the first color bar, these are all the args and quargs. I've specified that it's horizontal. And for format here, I have specified them to be percentages. And for the second color bar, that's on the vertical axis. I shrank it to 0.5 in order to make it fit that size. It tends to be way too long on the vertical axis. And I also gave it a format. And I gave it an extend equals both. And that creates those little pointy ends there. So for the key points that you have to remember that you should take away from this. So that's matplotlib is the essential Python data visualization package. It has nearly 40 different plot types to choose from, depending on the shape of your data and what qualities you want to highlight. Almost every plot will start by instantiating a figure, fig, which is the blank canvas, and one or more axis objects, ax or axes. And this is the most common command that you'll use to initialize a plot. And most of the plotting and formatting commands that you will use are methods of axes, but a few are methods of figure. And I strongly encourage you to consult the official matplotlib documentation. By and large, it's excellent. The only part that it doesn't do well with is like the logarithmic locators, which has some tricky stuff with it. Exercises and their solutions are provided separately in Jupyter notebooks, and you may want to modify the search paths in the file. The data file to do some of the exercises is this one here, the exoplanets 5250. All right. So let me see what other questions were asked. I'm not sure about CSense because I don't have access to it. I think you can use these IDEs. The thing that you can't do is that there are a few commands in for instance, Seaborn, where you have where you load data repositories online, and since CSense is not connected to the internet, you won't be able to do that.